All right, what's going on, my mathletes? That's right, Mr. Muscarella coming at you, and here is example number 3 for solving trig equations by factoring. So let's go ahead and take a really good close look at this one. But before we do that, let's review examples 1 and 2. So examples 1 and 2 dealt with sine and cosine, right? So sine and cosine, they're your x and y coordinates on the unit circle. Sine is the y coordinate, and cosine is your x-coordinate. Tangent is the ratio of sine over cosine, so you can find that by dividing the sine value by the cosine value, or, it's super duper helpful if you just go ahead and memorize that stuff. All right, all those values around there, which for the tangent, I've got there in red for you. So, one of the things with sine and cosine and tangent, they're pretty much right there. But when you deal with the other trig functions, secant, cosecant, cotangent, that's where we're going to have to also pull in some reciprocal identities with these. So we'll be playing with that as we go through each one of these, because it's going to make our lives a little bit easier. Now again, we still want to use that same process, right? We still want to make sure that we get our quadratic term on one side, set the equation equal to 0, and of course, make sure that quadratic term is positive. So we're going to start by taking cotangent theta right there, and we're going to move that over. And when we subtract cotangent theta from 2 cotangent theta, when we subtract those two, we'll just end up with a regular cotangent of theta. So cotangent squared theta. So I have cotangent squared theta plus, and then 2 cotangent theta plus 1, and that's going to be set equal to 0. Now from here, this is a perfect square trinomial. It's really similar to x squared plus 2x plus 1 equals 0. So same idea with that, same idea. So we're going to have cotangent theta plus 1. And then we're going to have the same factor again. Cotangent theta plus 1 equals 0. So with this particular problem, we have the same factor for both of them, which is going to make our lives a little bit easier, because we're only going to have to solve for one factor since both factors are the same. So we'll take cotangent theta plus 1, set that equal to 0, and then we'll end up with cotangent of theta equals negative 1. Now here's where that reciprocal identity comes in. So cotangent is not on the unit circle. So what we're going to do is take the reciprocal of both sides. So the reciprocal of cotangent is the function tangent. So those two are reciprocal functions. And then the reciprocal of negative 1, again, this is going to be one of the ones I want you to memorize. If you take an integer and take its reciprocal, it's going to, and that integer is negative 1, you're going to end up with the same thing. Pretty cool. Don't have to worry too much about that. So now I can look on the unit circle and say, where is tangent negative 1? So let's bring in the unit circle here for those of us that don't quite have it memorized. And when we look at that, remember, tangent is negative 1, where both your x and y coordinate are going to be the same in terms of square root of 2 over 2. Only one of them will be a negative. So the x coordinate or the y coordinate will be negative. And that occurs here at 3 pi over 4, or 135 degrees, and then down here again at 7 pi over 4, or 315. So again, in degrees and radians, theta, so our mystery angle is going to be 135 degrees, or 315 degrees. And in radians, that would be 3 pi over 4 and 7 pi over 4. And notice that these two angles are 180 degrees or pi apart. Pretty cool, huh? So that's the very first thing on that problem. So same steps, set it equal to 0, set each factor equal to 0, and then go ahead and invoke the reciprocal identities, because you're going to want to use those, because cotangent, I don't know, maybe some of you have that memorized, so if you do, good for you. But that's how I want you to show your work on these guys. So let's go ahead and move these guys out of the way as we go into example number 4. So let's go ahead and take a look at example 4. Now, if you think you got this down, good for you. Pause it, come on back, and let's see how you did. But if you want to go together, let's roll. Let me get that guy out of the way, and then let's go ahead and start this one. Ooh, nice challenging one here. So we're going to start by taking everything on the left side. We're going to leave that put, because if I look here at my quadratic term on the right side, this value right here is negative. So negative 2 cosecant squared theta. So I'm going to move that over to the other side. And when I do that, that's going to combine with this negative cosecant squared. And when you combine those two, of course, you'll end up with a cosecant squared theta. Moving the negative 2 cosecant theta over, you'll get positive 2 cosecant theta. And then that 1 that was sitting over there, that's just still positive. So plus 1 equals 0. So that's the first step. Good. Now we've got that. And again, this is another perfect square trinomial, which is kind of nice. So that means this is going to end up factoring into cosecant theta plus 1. And then, same factor again, cosecant theta plus 1 equals 0. So again, equal signs, nice, neat, lined up. Now, since we only have one factor to solve, then, or both factors are the same, we can only solve one of them. So cosecant theta plus 1 equals 0, which means cosecant of theta is going to be -1. Now, cosecant, so here's, we got to know our reciprocal functions, right? So the reciprocal of cosecant, now I always remember them like this. Sine and cosecant. So the S's and C's always go together. So I think about it like South Carolina. Maybe you've got another way to recognize it. And the same thing with the other one. If you have cosine, all right, so if you have cosine and then secant, so again, you've got your S's and C's going together. So cosine goes with secant. So those are going to be the reciprocal functions. Tangent and cotangent, they sound similar enough, so most people don't have to think too much about that one. But here we go with this guy. So the reciprocal of cosecant is sine. And the reciprocal of -1, so that's cool. So sine, where's my y-coordinate? Positive or -1. Our sine coordinate is -1. We've already done one like this before, and that is at 270 degrees, or that is all the way at 3 pi over 2. All right, so that's it. So thank you guys for watching this one. Hopefully by now you're starting to get the habit of solving trig functions by factoring. Just take your time, set each of these equal to 0. Showing your work and every step along the way. Again, if we were being graded, on a quiz, you get 1 point for getting your factor set equal to 0, 1 point for factoring correctly, and then of course you'd get another point for your values on there. So, but you've got to make sure all of this work here that's in between, you got to show that. If you just jump right to your answer, no points for you, bro. So don't throw away any points, and you won't go away mad. All right, sounds like an old song. Yeah. Anyway, you guys have a wonderful day. I love you guys. Hope you have a wonderful morning, afternoon, or evening, and I'll catch up with you again soon. Peace out.